So hello and welcome back to P Academy. So this is the continuation on the CAM profile diagram and CAM mechanism. So this is the part 3. In the part 1 we looked at CAM displacement diagram. In the part 2 we look at CAM profile diagram. And then in this part 3 I want to look like this is more like a practical explanation to how to draw the CAM profile diagram and how to draw the CAM displacement diagram and the CAM profile diagram. So this is just like the practical aspect of it. And the example I'm going to be using, hopefully it will be displayed on the screen, or you can check the description. I will leave the question there. But let me read it out. That's question 5. It says irradial CAM. So I'll just be picking out the important information and then we're going to draw it. So it says irradial CAM with 20 mm minimum diameter. So CAM diameter, we are told that is so let's just take it as 20 mm, minimum of 20 mm. So let's just note that. And then it went further to say for 150-degree camshaft rotation, the follower rise 30 mm. So that means it rises for 30 mm for 150 degrees. That's from 0 degrees to 150 degrees. So to 150 degrees, rises moving with uniform velocity. So take note, uniform. So that's uniform velocity. So what's the next? It said for the next 30 degrees, camshafts rotate, the follower dwells. Okay. For the next 30-degree camshaft rotation, the follower dwells. So that means for the next 30 degrees, that's from 150 degrees to 180 degrees, it dwells. So these are some of the informations we actually need. And then for another 120 degrees, so that is from 180 degrees to 300 degrees. So the follower experience a 30 fall, that means it fall with simple harmonic motion. And then finally the follower dwells for 60. So for the remaining 60 degrees, so that's from 300 from 300 degrees to 360 degrees, it dwells. So basically these are the informations given, and this is the information we need for us to draw the CAM displacement diagram and also the CAM profile diagram. So let's just do a rough sketch of this. So you're going to be having something that looks like this, and then we're told that it rises with uniform velocity, right? So it's going to be like this. It dwells, then it also falls with simple harmonic motion. It's going to have a curve that looks like this, and then it dwells again. So this is the 360. So now let's put this in perspective. So to start with, let's draw a vertical and horizontal line. So if you missed the last two parts of the video, you can just check the description. You find the link there, or you can check the playlist on the technical drawing. You'll find it there. All right, so let me see, which one should I start with? So let me just draw my straight line. Okay. So more like the x and the y axis. So let me just use that word. Okay. So the next thing I want to do is I'm just going to divide this into 360 degrees, and to do that I'm just going to be using, like I said in the previous part, you can use whatever scale that is okay for you. So you can say maybe for every 1 centimeter represent 30 degrees, or maybe 2 centimeter for every 2 centimeter represent 30 degrees, or 15 degrees, or even 1 centimeter represent 10 degrees. It all depends on you. Exactly. So if you are using 1 centimeter represent 10 degrees, so you're going to be having a line with a total length of 36 centimeter. So I hope you get the concept. So but for this now, because of space, I'm just going to be using 2 centimeter for should I use with 2 centimeter for 30 degrees be enough? Let me just be sure. So Okay, so let me just extend this a bit so that it can be enough. So is your space also, or that is if at all you are not giving, your space will also determine the scale that you want to use. So exactly. Okay, so let me just mark out the points. So that's going to be every 2 centimeter. Let me just note it. Okay, so this is it here. This will be 30 degrees, 60 degrees. This will be 990, and this here will be 120 degrees, 150 degrees, 180 degrees, and this will be 210, 240, 270 degrees, and then this will be 300 degrees, 330, and then here is this 360. So the scale, whatever scale you want to use, that's if at all you are not giving, is yours. So let me just, since the height here is just 30, so let me just indicate this right away too. So 1, 2, 3, this. So this is 3 centimeter, which is 30 mm. All right. So now let's get started. Now we also, from the information given, we were told that from 0 to 150 it went with uniform velocity. I've explained this in the part 1, so the meaning of how to do uniform velocity. So let's do that. So this is our 0 degree. So that means from here to here. So let me just try to get my reference points. Okay, so that means from here to 150 degrees. So let me just use so that's 1, 2, 3. So let me just use short dashes. So we are told from 0 to, so this is the point of intersection here. So what we are just going to do, since the question says it rides with uniform velocity, so from this point here exactly to the origin, just draw a straight line. So this straight line can make it bold. So that's the first one. So the next information says that from 150 to 180 it dwells. So that means from 150 to 180 it just move horizontally, straight horizontally. So let's indicate that. So this is the 180 mark. So what you just did, so you continue, that means from here to here. So then the next information there says from 180 to 300 it falls with simple harmonic motion. So from 180 to 300, remember the question said for another 120 degrees, so I've added it up, 180 plus 120, that's 300. So that means from 180 to 300 it falls with simple harmonic motion. So let me take note of that point also. Okay. Let me just use this. So if you're using a t-square, you might not need to be doing all this that I'm doing. So once you just place your set square on your t-square, it should give you the correct result. So it says from here to, so for this particular region now, it falls with simple harmonic motion. So now, and I've explained it in the part 1 of this video, how to go ahead with when they say something falls or rise with simple harmonic motion. So let's just put that into practice here. So like I said, you're going to be drawing a semicircle. So if you want to draw a semicircle inside the diagram, make sure they are faint. Exactly. So make sure it is the semicircle and everything is going to be faint. So since the question says the height here is 3, so I'm just trying to point out the middle, which is 1.5, which is it here. So I'll bring in my compass now and measure 1.5. So now with a radius of 1.5, I'll just draw a semicircle on this part. So don't forget, I said it should be faint. So, well, but I'll just make it bold so that you can see it, but make sure it's faint. Because the semicircle is not part of the diagram itself. It's just a way of letting you get what you want to achieve. And if you're asking, you can also decide to draw yours after the 360 degrees. So that means probably somewhere at the side. Exactly. It's not necessarily you draw it inside. But if you are drawing it inside, make sure it is faint. Alright, so I want to just get this this short radius. So the next thing is to divide this circle into 6, the semicircle rather. So like I said, with the same radius you used to draw the semicircle, you place it on this point, you draw an arc, you place it here, you draw an arc on both sides. So then place it here also. You draw an arc. So where it is touching, where those arcs are touching the semicircle, you draw a line to the center of the semicircle. So please don't forget, these things are to be should be faint lines. So now the next thing we are going to do is this. We are going to draw horizontal lines from this point here, from this point to come and touch here. Exactly, because this is the space where we want to draw that simple, the fall with simple harmonic motion to this place. So to help us achieve that, I'll just have to bring out my set square again, because the line has to be parallel, from here like this. So just making sure. So from the center also. And then from here. All right, so I've just divided it I've just drawn this line. Now the next thing is you're also going to divide it vertically into 6 equal parts. Now, like I said, then depending on the scale that you use, you might, this is like 8 centimeter. So let's assume you want to use, where's my calculator? So let's assume you want to do the division. Okay, my calculator is not close. Anyway, let's just say you are not you can't divide it easily like that. So let's just use line division method. So at any convenient angle, you draw a straight line. So you can do it below, you can do it at the top. So it all depends on you. So you're going to divide this line into 6 equal parts, or not necessarily divide the line into 6 equal parts. So you're just going to bring your, so with your compass, so you place it here, and then you bisect the lines into 6 intervals. So 1, 2, 3, 4, 5, and then 6. Exactly. So what we want to do now is, I don't know if you can see it. So what we want to do now is from this point here to the last one here. Remember, this is, let's say this is 0, 1, 2, 3, 4, 5, 6. Exactly. So those 6 divisions, the last one here, you join it with this one here. So all these things are still with faint lines. So once you join it, you are just trying to transfer lines. So this is how best you can do it. You use your what's it called? So use your set square to just continue. And maybe I don't know if you are seeing it. So for me to continue, I'll have to place my set square on this other side like this now, so you can see it like this, and I'll slide the 30 degrees set square on it. So I'm going to be having something like this. Okay, I think it's not working on that angle. Okay, so there's no exact method on how to, you just have to understand how the process. So I just have to, so what I did is, let me just show you. So I just slide this a little bit down so that to give it more space on this side. Then I can place it here. So what I'll just do is just slide it like this, and then okay, so it's giving us what we want. All right, so we've transferred all this line on all these points, and so these are the points. So if you are to divide it into 6 equal parts, so these are the points that divide this line from 180 to 300, are divided into 6 equal parts. So these are the points. So what we just have to do now is to draw it vertically. So for us to do that, so I'll just be using my set square again. So like I said, if you are using a t-square, what you just have to do is just place your set square on your t-square. Let's just say this one is acting as my t-square. So you can then transfer these other lines. So from here, I draw the vertical line. From here, And don't forget that all these ones I'm doing right now, they are to you're supposed to do them with faint lines. So are we good? Now for next thing is to take those points that is going to form the curve. So let's just, for proper understanding, let me just call this point 0, 1, 2, 3, 4, 5, 6 exactly. And then on this side, this is for the horizontal one, this is 0, 1, 2, 3, 4, 5, 6. So for you to get the point of intersection, if you follow this numbering, this arrangement from here 0 here to 6, from 0 at the top to 6 down, so just note point 0 and 0, point intersection of 1 and 1, the intersection of 2, vertical 2 and horizontal 2, vertical 3 and horizontal 3, vertical 4, horizontal 4, which is right here, 5 and 5, 6 and 6, which is right here. So the next thing you will need is your French curve, or so your French curve, your flexible curve, or whatever curve you think you have access to. So use it to join those points. So, and in most cases, this 3 is always a straight line. This 3 is always forming a straight line. So then for the other parts, so let's just see the one that will work best. Okay. All right. So then for the one below it, so if you are wondering how do you get the point in using the French curve, best as I can say, the more you do, the more you understand better. So we've been able to do, we've done this, we've done the dual, we've done the fall with simple harmonic motion. Exactly. So the next thing it says from 300 to 360 it dwells. So that is pretty much simple. So that means what happens there is from 300 to 360 is just on this line itself. So it's on this line. Are we good? So we've just drawn the, let me see the question again. So we've just drawn the follower displacement diagram. This is like the question I part. So the next one is to draw the cam profile. So for the cam profile, let me just do it at the back here. All right, now for the cam profile, remember the information that we are given. We are told that the cam has a minimum radius of, minimum diameter of 20 mm, which is 2 centimeter. So what you just do is to construct or to draw a circle with a diameter of 20 mm, so which is radius of 1 centimeter. So you bring in your, so you can decide to use more than 20 because the question says a minimum diameter. So but let's just work with that 20. So I'll just measure 1 centimeter. So if you are finding value in the video, please give it a thumbs up, and if you are yet to subscribe still, please click on that subscribe button. So I've measured 1 centimeter. I hope you can see it. So I've just measured 1 centimeter, which will be the radius. So now for you to get that of the next one you are going to draw is the height of the displacement from here to here, the maximum displacement, which is 3 centimeter. You add it to the radius of this circle that we've just drawn, exactly, of this cam circle, which is, so that's going to give us 4 centimeter. So I'll measure 4 centimeter. So I've explained all of this in the other part of the video. So this is more like Okay, so this is the 4 centimeter. So from the same center, alright, so let's divide the circle into 12 equal parts. Like I said, because we've divided it here into 12 equal parts, so that's what we're going to use. Now, if you divide yours into probably 8 or 18 or 12 or 10, depending on whatever scale you use, that is what you're going to replicate here. So make sure your division 2 is very accurate. Okay, so I've been able to divide it into 4. So the next one, I want to divide it into 12 equal parts now. So in doing that, so with the same with a radius of 4 centimeter that I used in drawing the circle earlier, so I'll place it on these 4 points. I hope you can see it, and then I'll draw an arc on both sides, so to the left and to the right. Alright, so I've divided it into 12. Now, like I've received a question like that, like, oh, I divided mine into 12 and it's not passing through the center. Most common mistake that could have happened is when you divide yours into 4, probably your vertical and horizontal line, they are not at 90 degrees. So once that happens, if you are trying to divide this into 12, everything will not, some of them will not pass through the center. So you have to take note of that. Alright, so at this point, now the next thing is, so let's just, this is going to be 0 degrees, it will be 30, 60 degrees, 90, 120 degrees, 150 degrees, 180, this will be 210, 240, 270 degrees, 300 degrees, 330 degrees, and then back to 360. Exactly. So the next thing you want to do is, you are going to transfer, I hope you can still see it here. So you're going to transfer the height of this displacement diagram here. So this is what I'm talking about. So you bring in your compass again. Now you measure, use your compass to measure the height of, so starting from 30 degrees, so you adjust it to the height of 30 degrees. So which is very small. So okay, so this is it, the height of 30 degrees. So you come here, so to where you have, let me just use, so where we have 30 degrees, we place it like this, and then we are going to draw an arc on that line. Exactly, this is it here. So you go to 60 degrees also. So use it to measure the height of 60 degrees. Come here to where we have 60 degrees. I hope you can see it. So you're going to do it round. So you go to next one we have is 90. So 120. So for 120, Then for 150 is at the maximum, so definitely it's going to be on the circumference of the outer circle, and including 180. So I can decide to skip that. So let me go to 210. So this is 210. So you have to be careful here so that you don't mix the points for the angles with the vertical lines that we draw here. So for 210, okay, so for 210, this is it. Then the next one is 240. You adjust your compass to the height of 240. Then you come here. So you place the pointer, the pin or the pointer of your compass on the smaller circle, don't forget. So that's for 240. For 270, so this is 270. And then on 300, so for point 300 now, 300 lies on the circumference of the cam itself from 300 to 360. So the next thing I'm going to do is, you see all those points that we've just marked. Exactly, you're going to use your French curve, your broom, your flexible curve, whatever you find convenient, you are going to use to join them together. Exactly. So let me quickly do that. Alright, so basically you'll be having something like this. So once you use your French curve to join those points, then you would need to indicate the you said it's a knife edge. Let me confirm that. It's a knife edge, so you have to indicate it with something like this. Alright, so this is how you just go ahead to draw the cam profile itself, and then you can just go ahead and answer the other questions. I think I explained it in the part 2. So it says as 225, okay, as 255 degree, what will be the displacement of the follower? So just locate 225. 225 should be in between 240 and this, somewhere here. So at this point, you trace it. Let me just, alright, so let me just do a demo. Alright, so if 225 degrees somewhere, it should be between 240 and 270. You trace it to where it is on there. So you just trace it to where it is on this vertical line, then you measure the height here. That answers that. And then at displacement of 20 mm, what will be the angle of rotation? Like I said, then you measure 20 mm here. This is 20 mm here, and then you try to figure it out where 20 mm lies on the, so where 20 mm lies, and so 20 mm is somewhere here, is also here, so you can trace the angle here, and this is it here. So you can just, you might not get the exact value, but you can just get the approximate value or something close. So basically that's the real practical solution to question 5. I hope it's clear enough. So far I've covered up on cam and follower. So if you have any other questions, just drop them for me, and then if you find value, please give it a thumbs up, subscribe if you are yet to, and then I'll see you all in another one, and wish you all the very best in 2002.